Bismillahirrahmanirrahim. So today we have seminar about the simulation and modeling software in civil and structural engineering. So we will discuss in detail how we can simulate the structures in engineering, and particularly in civil and structural engineering. So why we need the softwares, or why we need the computer modeling and analysis? So as we know, there is a very highly trend of softwares or computers, and new very fast computers. So now we are shifting the manual calculation to the advanced calculation by using the softwares. And nowadays the engineering or design, structure analysis design is very easy as compared to previous years. And like in last decade, it takes more time. But nowadays we can solve very big complicated problems in 1 week or 2 weeks. So it will save us our time also, and it will also affect our economy of the projects. So how we can introduce the software in our education system, particularly in civil engineering. So I will explain different fields where we can apply the various softwares. So this presentation will also cover the widely used software all over the world, especially in structural engineering. As we know, the information technology and computer technology is growing very fast. So we can apply this technology in case of construction, in project management, and also in the structure design and analysis purposes. So the advanced computing technology like high performance computing is very important to solve the very complex civil engineering problems. Before this, we need it for the basic knowledge of the softwares also and mathematics in our civil engineering if you are studying courses. But at least you should know how you can solve those problems by using the advanced computing technologies. So we started applying the computer technology since 1970s, because during 1970s there will be advancement in the computer technology. So we also apply the some programming like basic programming in the civil engineering field, and based on this 1970s, after that there is continuously improvement of the engineering or the structural engineering software computing technologies from day by day. So this will provide us the basic information stored from the 1970, and now we are in 2023, 2022. So at least there are 50 years we introduced the engineering softwares in our civil engineering. So at least we have more than 50 years, okay? So like SAP 2000, they started to use in 1970. Now is more than 50 years. So there is some advancement also in the software computing and technologies. So there are various softwares we can use in the civil engineering, and also there are programs like you can make your own program like MATLAB, or you can make something new version in C++, and you can also like make your own app, like a app in the mobile. How to design your small specific problems, you can make it by yourself. But we can also apply the same civil engineering softwares in different technologies like engineering, structural engineering, transportation engineering, hydraulic engineering, environmental engineering, and basic construction management softwares also. So these are the some disciplines of civil engineers, okay? So after your graduation, maybe you will specialize in some fields, okay? Well, like I'm specialized in structural engineering, maybe transportation engineering, geotechnical engineering. So you can go for those fields. And you can also apply some knowledge, basic knowledge you learn during your undergraduates, and then you can apply the knowledge in your software programs. Normally, we use the software in civil engineering based on the some like architectural purposes. Like you did a, engineering drawing, you use AutoCAD in architectural how to draw the models and everything, like in AutoCAD or Autodesk some applications. Then you make some architectural model. Then we need to do some structural analysis or structural engineering model. Okay. So what is the basic difference between architecture and structural? In architectural, we just propose some building or some design, okay? You make some sketch or something, but in structural, we apply the loads, okay? And we also decide the sections, properties, how much steel we require, how much the section of the columns and beams we decide on it. What is the project management? Yes, after once we finish our design, you work on the site, okay? So at the site, you need to manage your projects, okay? How you can manage your projects? Like you had different activities start from the soil survey, soil land survey to the final construction of the project, okay? For the completion of your buildings or any bridge or any project you are working, okay? So we can also apply some project management softwares also after once during the construction of your projects. Okay. So architectural softwares mainly focus on the planning, designing, and interior and exterior as you study in your engineering drawings, civil engineering drawings. Okay. So just design the plan of the building, and then if you go more advanced, you can make a 3D plan of the building. And if you want to see more advanced, you can apply the virtual reality. Okay. You can see how the building will look like after you complete the projects. Okay. And then structural software will help us to analyze and design the structural members so that it will be safe. Okay. So all structure must be designed so that it will resist the wind and it will resist the loads and it will resist, it will sustain during the extreme conditions. Okay. Sometimes there will be earthquake, sometimes there will be big wind or typhoon. So we should design this buildings or projects based on our structural knowledge. So software will help us in this case. So there are so many computer applications. Okay. Now currently you already study the 2D drafting. Drafting means how you can make a plan of the buildings. Okay. In AutoCAD, 3D modeling, like you can virtually see enter the building model and you can see how the building will look like after your construction. Then animation will show you how the loads will react on the building after you make a model. So what will be the displacement, what will be the shear force bending moment diagram, or some type of earthquake simulation or wind simulation on your models. Okay. Scheduling, like we did in the project management, we have different activities. Okay. From beginning of the project till the end of the projects. And finally, we can also do calculations by using the computer applications. In the project management softwares, normally we use this Primavera and Microsoft project. Okay. You know Primavera? No. So Microsoft project, do you know? No. A Microsoft project is same like MS Excel, MS Word, okay? Same thing, MS project is there, okay? So this is very convenient and easily available. But Primavera is a very specialized software, okay? Maybe you will study in your project management course, or once you are doing some your bachelor thesis or bachelor senior design projects or masters, you will use the Primavera, okay? So these are some softwares. So these are the structural softwares we have, and then we have the architectural softwares. There are so many softwares are available, but mostly the widely used in the world are reliable softwares are very important. Okay, so this is some of the list we use for structural purposes. AutoCAD is basically for drafting purposes, but you can do some structural calculation, like area of the sections, or what about the area of the your land or something. You can do some calculations also in AutoCAD. Okay, and this is CAD software also, G Star Pro. This is also CAD software. Straight Pro is very famous software. STED is a structure analysis design and drawing software. Okay. Normally, you know, structure analysis program SAP 2000 you are using in your courses like structure analysis 2 or BRICS design. So in the structure SAP, we only just analyze the building, also design the building. Okay. But in case of STED, we can also print the drawings. Okay. If you're a big plotter, you can also print the drawings. You can see the detailing of the concrete columns or beams or further. The drawings are very important, which can be used at the site. Okay. On the site, you cannot use like computers or something which is so you need a printed drawings. Okay. So you can check on the site. Nowadays the iPad and laptops are available, or phone, you can check the drawings on phone also, but we need the printed drawings also. Okay. So this is one of the big advantage of this software, that you can print the drawings also. ETABS is an extended three-dimensional analysis building system, which is used particularly for the buildings. Then the structure analysis program we use for the analysis purpose. Tekla is also used for the like on the site software. We can do analysis, and we can also do the project management by using the Tekla software. Then this is a slab analysis of finite element. So this is used only for the slabs. So these are the slabs. We have different type of slabs like wafer slab, one-way slab, two-way slab, rib slab. So we can use this specialized software. Then we have ANSYS. ANSYS also is a finite element software, basically used for the mechanical engineers. How many of you are from mechanical? No, all of you are from civil? Okay. So we can also use ANSYS in civil engineering, but ANSYS is also used by the mechanical department. They have the license software. So normally, if I need some ANSYS help, I will go to the mechanical. So they can the mechanical lab. This software was already installed. Okay. In our civil engineering, we have SAP 2000 license software, which is installed in our computer labs. Then quantity survey. What is quantity survey? This is also very important. How you can calculate the cost of the buildings or projects by using the quantity survey. Okay, quantity means we need to calculate the quantity of the excavation and the foundation, how much concrete you require, how much will be the cost of each material. Okay, how much the cost of the fall ceiling or HVAC, everything from A to Z we have to calculate in the quantity survey. And this is very important before the approval of the project. This will give us the final cost of the project. Civil 3D CAD, this is also very good. It is same like STED Pro. This is more structural based software, but in this you can also apply the environmental or geotechnical or field of civil engineering. So these are architectural softwares. AutoCAD, you already know, it's free. You can license, educational license, you can use on your laptops. How many of you are registered with the Autodesk? Is a student is a student license? All of you. So you can online easily use AutoCAD product, Autodesk products. Okay. So these are the Autodesk products. Some of them are Autodesk products like AutoCAD, Revit, Archi. These are some Autodesk products. Okay. And something are missing. So Revit and some 3D recap or some more products you can find it on AutoCAD, Autodesk website. 3D Max is like you can go inside the building and see how the building look like. Revit Archi is like a, structure design software, structural drafting software, steel drafting software, in which we can see more detail of the rivets, like guess the set plate or section of the steel columns or designs, beams. So we can further go in this. ArchiCAD is same like AutoCAD, but this is a different product from the Autodesk. This is also another software. This is also software used for the architectural purpose. Google Sketch. Normally, if you are not an engineer, okay, so you want to make your own home. So someone from the college student or high school students, so they want their own design their own home. Okay, so they try to use the Google SketchUp. Okay, even some you are not a civil engineer, so some mechanical or some other people wants to construct their home, so they use the Google Sketch. Okay, this is another. Rhino is very important. Rhino is actually is a structure analysis software. Okay, So they already have the license, and there is some seminars under the Saudi Building Code or Saudi Council of Engineers. Okay, so they organize here outside also in Medina. Yes. We use Revit. Yes, yes. You can Revit. You can download it from the Autodesk. Okay, and it's free. You can use Revit as a structure analysis software. Okay, and mostly it's used for the steel structures. Okay, steel structures you can easily use the Revit also. Even concrete you can also use it. Okay. So structure engineers preserving the past. Okay, while building the future. So we are so preserving the past and building the future. Okay. So every monument that is testament to the like humanity stand today only because the structure engineers was involved in its creation. Because we are very important, because we need to create the skyscrapers or so many, like you see, buildings or some mosque or some bridges. So and some monumental some like structures or some stadiums. So this is very important knowledge for the structures. Okay. So we also preserve our heritage. So mostly there is a CSI company, Computer and Structure Incorporation company. So this is who built the SAP 2000, Structure Analysis Program 2000. Okay, so which include the ETABS, bridges, SAP, or SAP. Okay, and different softwares they use it. Okay, and then we can see how this software can present the past, present, and future. You can turn on the light, okay, if you want text of it. Can you see? No? Okay. So how can we, CSI is very important because this all is a revolution in the structural engineering. And we have the past, present, and future for this. They started to work in 1970 until 2023. They have a lot of improvement in their softwares. And then how they develop the softwares from the 1960, they work on the equations, okay, from the beginning of the structural analysis. Then they make some small calculations like matrices or something. From there, they use 1963, they apply those equations in their computers or in their programmings. Okay. Then we have 1960 and 1965. Okay, we have very small softwares or something which is not as advanced as we have currently, but they are used for the structure calculation. In 1969, the Professor Edward Wilson also introduced a structure analysis program. Okay, this is a SAP, a structure analysis program. So this is in the Berkeley in the California. He introduced this software, and from here we start to apply the computer knowledge in our civil engineering projects. Okay. Further, he think that SAP is a general program, so he used to develop a specialized program, ETAP, extended three-dimensional analysis of building systems. Okay. In 73, then he also built some programs in SAP 4, so different version he started. Okay, SAP 1, 2, 3, 4, like this. In 1985, they used the SAP ATI, Structure Analysis Program ATI. Okay, so this is one of the most advanced software at that time. Okay, then new era came. Okay, so Professor Wilson and Professor Clough, because they introduced the earthquake engineering at that time. There was so many earthquakes in 1980 or 85. There are big earthquakes in California. They think that the structure will not sustain the earthquake forces. Okay, so they introduce more advanced dynamic analysis of the softwares. Okay? And then they think that they need more complicated, more also the like accurate softwares. So this is a dam model, and this is a foundation of the dam. So they tried to, there was some damages due to the earthquake in the dam. They want to make a word safe and better, okay? So they introduce more structural knowledge or finite element knowledge in the softwares. Then Dr. Ashraf Habibullah is one of the, he is the owner of the CSI, Computer and Structure Incorporation, Computer and Structure Company. He graduated at Berkeley. He was the student of Professor Wilson. Then he took over the SAP 290 SAP company or SAP software by his own, making a new company. Then he also used some structure analysis and earthquake knowledge in 1975. Then he make some more advancement in this software, okay? So then he start, then SAP 90, SAP 2000 will start. So when I was a student at my in the Bachelor of Civil Engineering, I used SAP 90 at that time. But currently we have the SAP 2000 version 23 because we are 22 or 23 they are using. And then these are the list of the engineering software. Okay, you can find it on the Wikipedia. Okay, so there are big list of the software you will find. Okay, and this list, some of them are easily available. You can download it and you can use it. Okay, so they are not like you need some knowledge of the Fortran or MATLAB or C++ or basics, but you can have the 156 softwares you can see in Wikipedia. Okay. And then there are many structural procedure and design codes we use, okay? Like Eurocode, American Society of Civil Engineering Code, and Saudi Building Code, okay? So this is why the codes are important. So this will make a proof, or there is a final safety. All the procedure must be approved by those codes, okay? If you are designing some building, so that can you should follow the some codes, okay? The code will tell you how much will be the material property, what kind of material you will use according to the local environment, okay? Normally in the Saudi building, we can have the detailed procedure how you can analyze your buildings or beams and column by using different procedures, okay? So before Saudi building code, we use American codes and Euro codes. In Europe, mostly they use Euro code. All of codes are normally the basic things are same, okay? But like we have the temperature in Saudi Arabia is different than other countries, okay? Even in the Europe, the cold regions, they have the different conditions, environmental conditions, okay? Only environmental conditions are different, but the basic procedures are same, okay? So this is the softwares normally we use in structure analysis from this Computer and Structure Incorporation Company, CSI, okay? SAP 2000 is widely used. Actually, all software are same, okay? We can basic purpose, we can do the same analysis from by using the all softwares. But they are more specialized, like structure analysis program. There is more options to analyze the structures here, okay? For CSI bridge, we can also use the same SAP 2000, either or we can use the for bridges. We can use the specialized software for the bridges by using this software. Then for buildings or skyscrapers, normally ETABS, extended three-dimensional analysis of building system. Okay, so ETABS is used for the specialized buildings. Okay, like Burj Khalifa or in Riyadh, there are so many buildings who are analyzed by using this. Even the World Trade Center. So there are so many studies they use ETABS. SAF is a specialized software in the slab. Then Perform 3D is used for the performance-based design during the earthquake. How the building will perform during the earthquakes. We use Perform 3D. CSI plant, like petrochemicals or petroleum industry or chemical industry, we use this software for the industrial purposes. This is CSI call is like a column in the buildings, in the bridges, or where in the piles or piers we use the column. Okay. Then BIM, building information and modeling. Okay. What is building information and modeling? Like in the project we are working, we have different activities. Okay. So we can see build the project and information, we see the information how the activities were completed and how then can be modeled according to those information. Okay. So we can use the BIM models or BIM building information model on the project sites also. Okay, Revit also we can use the software during the execution of the projects. Okay, during the construction of the projects. CSIK, so normally we can update our drawings according to the site. Okay, so we can use the drawings, this software to update our drawings. So 3D model are linked with each other. Okay, so all components like ground floor, first floor, or other mechanical facilities or utilities or some other things. So all projects we can analyze, or we can make a model using 3D models. Okay, so this is one of the software we can use, and we see different activities of the construction in this software. Okay, so this is another software. Here we can see inside of the construction activities also. Okay, so BIM is shaping the present. Okay, building information modeling, in which we can see the current construction activities. Okay, in different conditions. Okay, at the site or even the office, or what is it, planning, cost monitoring, facility management. So everything is controlled by the BIM nowadays. Okay, building information modeling. And then there will be real cracks in the due to the failure of the loads. Okay, so we can make a real cracks or model those columns or beams to view the real cracks of the structures. Okay, as a structural engineer, we have the big responsibility. Okay, we need to design the safe structures, or we can have the enough technical background knowledge. Okay, and then this is how the computational software will design your bridge projects or some complicated projects. Okay, so we cannot limit our design softwares. Okay, we can make more detailed calculations or verify our calculations as well. Okay, so then there are so many intelligent ways to make a 3D models. Okay, and there are more computational use also, and there is a lot of flexibility or options available to choose different models. Okay, so future of structural modeling is very big. Okay, so there are so many complicated structures or tools, or even the artificial intelligence is very important nowadays, AI. Okay, we can also apply the artificial intelligence in our civil engineering software or analysis. So this is also, structural engineers are very important. Okay, they protect our life also. We build the design, sustain the earthquakes and winds. Okay, so we are, this is very important thing that we are doing our job. Okay, and then this is ETABS introduction, so extended three-dimensional analysis of building system. So this is also one of the good software to design the bridges. And this is a ETAB model. Okay, so there are maybe ground plus how many stories? 25. Okay, more than maybe 25. So we can easily solve those structures, like we study the force method or slope deflection method or moment distribution method in our courses. So only we can solve only one beam. Okay, you know, one beam will take much time. Okay, but in the software you can solve so many thousands of beams. Okay, or thousands of columns, so it will make more time. But this is also very important. Okay, we just don't rely on the softwares, but a software will give you some results which you don't know. Okay, maybe it's real or not real. We need to verify. How can you verify? Based on our knowledge, we can verify it. Okay, in the structure analysis program 2000, SAP 2000, you can solve all type of problems in this program. Okay, like strength of material, reinforced concrete design 1, reinforced concrete design 2, structure analysis 1, 2, all kind of problem you can solve in this, in those softwares. Okay, in this structure analysis program. Okay, so you can also use the engineering, civil engineering drawings. Okay, you can make a plan in the AutoCAD. You can just export in the SAP 2000, and you can put some loads, and you will get the deflections and results in this. Okay, so we can do a lot of modeling using the SAP 2000. Then This is the one of the model of the building in sub 2000. This shows the deflection in the beams. Okay, so like we have the yellow, red, show the different stresses in the beam, the critical stresses and the normal stresses. This is also showing the stresses in the beam. Okay, we can also see the shear force bending moment diagrams in the softwares. SAF, slab analysis for finite element. Now this is used for the slab. As we see here, the waffle slab or two-way rib slab. So we can see analyze any kind of slab in the SAF program. Okay, this is showing the stresses in the SAF. Okay, like you are doing the slab analysis in your structure analysis 2 project. Okay, so here we apply the load. So here this color, purple color shows that here more stresses. Below may be less stress. Okay, so then we have the more stress. Here we don't have any stress. Okay, so this is how you can plot the stresses in the slab. You can use the same model we use in our structure analysis 2 project. You can plot the stresses in that also. Okay, AutoCAD you already know. Okay, with the help of AutoCAD we can make drawings. Okay, detailing of each drawing or each project, like house or rivets or any kind of the drawings or column or beams we use for the construction, we use in AutoCAD. So normally we have the architecture plan. Okay, in architecture plan we have like a plan of the building, elevation, sections. Okay, how much will be the thickness of walls and something like this. Okay, then structural drawings. What is structural drawings? In the structural drawings, we also draw in the AutoCAD. Okay. In the structural drawings, we know. Are you studied RC1 or 2? RC1. In RC1, you design a beam. Okay. In the beam, you design the steel section. Okay. You know how much number of bars you use in the section. Okay. What will be the size of the section? Okay. These are the structural drawings. Okay. We draw the structural drawings in the AutoCAD also. Okay, and but in the structure analysis program like STAAD Pro, this will give you automatically. Okay, but normally we first do the architecture plans. Okay, then we model it in SAP or some structure analysis program from where we know how much steel or section we use. Then we plot the structure drawings. Then structure drawings we give to the site engineer. He will construct the buildings. Okay. These are some AutoCAD, some specialized languages we use. Okay, AutoCAD LT. This is something we use some subroutines inside the AutoCAD. Okay, this is 3D view of the building. Okay, we can see the stairs or room windows or 3D view of the buildings. This is another software, G-Star CAD. This is same like AutoCAD, but we have some different options in this building. Here we can see 3D model of the building and also 3 extruded or 3 virtual view of the model of the building. This is also one of the software we use instead of the AutoCAD. And this is also how we can see the different sections or floor inside this software. STAAD Pro is very important. Like the best, I think, is a SAP, Structure Analysis program. The second widely used program is STAAD Pro. Okay, STAAD Pro is also used for the structure analysis, also for the drawings, also. Okay, so this is also used for the architecture purposes, structural purposes, and also we can model the steel and concrete in this. And this is a building which show us the 3D view of the building. So this is here we have the foundation. Okay, and in the middle we have the elevators. Okay, we can make a model like elevators. Then we have Tekla. Tekla is also one of the software we use during the construction and infrastructure management also. Okay, we can construct the building inside the Tekla. Like we have the big auditorium. Okay, you find the construction crane, everything in everyday activity you can monitor by using this software. ANSYS is normally used for the mechanical engineering, but we can model the blast loading or fire or impact of the fire or blast inside the structure by using the ANSYS. MATLAB, you already use the MATLAB also in your forces. Okay, we use the matrices calculation in the MATLAB. We also you are studying the stiffness method of analysis. In a stiffness method of analysis, there are a lot of matrices. Okay, you can multiply, divide, and subtract it by using the MATLAB. What is MATLAB? What is metric? M-A-T. Matrix. Okay, matrix is a laboratory like this. Okay, so you can see the different on the graph from various forces or stresses also in the MATLAB. Quantity surveying is very important. Okay, from quantity surveying we can either use the built-in softwares or we can use the Excel sheet also to calculate the quantity survey. Okay, so from here we can check different activities of the projects. Civil 3D, we can also, like big infrastructure planning, urban and infrastructure planning, we can get, like in the Google Earth, we can see the 3D view of the buildings, okay? But we don't see the height and actual plan of the buildings, okay? So we can get information from Google Earth. We can see how the buildings will look like, okay, in this 3D building. Architectural 3D Max is also very important, okay? In 3D Max, we can model the 3D view of the building, okay? Once you are working in the, like in a company, okay? This company is architecture company, are selling some houses or flats, okay? Very small models, okay? So they can show you how the building will look like after construction, and this is your flat and you want to buy and how it will look like. This is some demo purposes, and virtually you will see how the building will look like after the construction, okay? Revit is very important. Revit we can also use for the calculation, or windows, roof, doors we can place here, and we can see how will they look like, okay? Building information modeling is nowadays very important. So in Revit architecture, we can further see how the inside of the building or lab will look like, okay? We are designing a lab, how we can place each equipment in the lab, we can draw in the Revit. Variants is also one of the software. Rhino is also one of the software we use for the analysis purposes, also for the architecture purposes. ArchiCAD, this is showing the railway station. We can simulate this railway station by using this ArchiCAD. And we have this another software, Navisworks. This is also very good, like Revit. This is see how we can simulate our house after construction. Google Sketch is very simple and easy, okay? Like everything you don't know, you type on the Google, it will give you answer, okay? Same thing, you can make a Google Sketch very easy, okay? For your home. If you don't know AutoCAD or Drawing, maybe they are licensed software, so you can easily use the Google Sketch to build your home. And this is Canvas is also another software. This is very important. We can convert our drawings into the like our printed drawings in the AutoCAD drawings. Okay, just we can scan to CAD. Okay, so then we can just it will convert the like printed drawings into the AutoCAD drawings. Okay, so software needs is very important, because without softwares we cannot work nowadays. Okay, you also work on the site, but if you are working in a design office or in consultant's office, the knowledge of softwares are very important. They will ask you which software you use in your civil engineering. You can tell them you use MATLAB, you use SAP 2000, you use C++, okay? So something they will ask you during your after your graduation for the job. And we can have the software application for different purposes, okay, like management and sketch, okay. So management, we use Primavera. You can see different activities here, okay. Gantt chart. What is Gantt chart? Gantt chart normally for your projects, like a senior design project, you will make a Gantt chart, okay, which show which activity you will take how much time, like 1 week, 2 week, or 3 week, okay. You prepare different activities with that different timelines, okay. So this is showing the construction project activities and how much it will take you prepare. So you can use MS Project or Primavera both. Primavera, like building foundation and the roof slab. roof columns, every activity and how much time it take, and when you complete it, it will show everything. Okay, from the month and year when you complete the project, it will show every activity. MS Project is very important because it's very easily available. You can make your own MS Project because Primavera is a specialized software and licensed software. MS Project you can easily use in like Excel. So these are the modeling softwares we use. Okay, and drafting software we use like Vectorworks. Also we use like Adobe Illustrator. Okay, to make some drawings or plans we use it. Or smart app, you can make your own smart app softwares. Okay, for smart app like how to design the beam, how to design the column, how to design small calculations or matrices. You can make your own app also. Okay, nowadays at the field or at this, in the construction site, the some engineer who is working on the site, they use some smart app. Okay, like like a geometrical calculation of highways or something small formula, they make their own app and they frequently use at the site. Okay, virtual reality. Okay, virtual reality is very important. Okay, but VR is very, very important. Okay, virtual reality will show how your project will be look like after construction. Okay, and how much the earthquakes or loads will affect, how the simulator, how your project will simulate after applying the loads. Okay, so nowadays virtual reality is also very important. Mostly the engineers are also working on the virtual reality also. GIS, GPS softwares, remote sensing. What is GIS? Like we use Google Earth. Okay, topographic survey using the Google Earth. In survey you study the GIS, I think. Yes, the Google Earth. So you can use in the land survey or something by using the GIS also. Okay. So we use also other softwares, Energy Plus or some building energy simulation or transportation simulation also we can perform. So there is a lot of scope of the softwares. Okay, can use in civil engineering or structural engineering. Okay, so there are so many like fields or projects they are using. Okay, basically in Saudi Arabia, they the big projects they designed by the some American or European companies. Okay, so they design it and they need some information or some engineers from Saudi Arabia, so they will hire you, they will make you something because they design the software in Europe, but it cannot be implemented here. Okay, so it needs some modifications, some improvements. Okay, so this is also very good that you can use softwares in this in your jobs also. So the conclusion is that softwares is very important. Okay, so before the application of softwares, it will take more time. Okay, it will take maybe 2 years, 3 years. Okay, before we construct the buildings, but with the help of softwares we can easily manage our projects. Okay, so it will help us to take less time. Like in the analysis, if we do this ground plus 4-story building. Okay, if we do the calculation for this building, it may take maybe 2 or 3 days. Okay, but with the help of softwares, you will perform this activity within maybe the 6 hours or 7 hours. Okay, or 3 hours. So it will reduce time and also save a lot of the activities. Okay, so this is all about the application of softwares. I think I just covered the structural software and some software in civil engineering, but you will find so many software in geotechnical engineering, in transportation engineering, or in also surveying. Okay, so there are so many softwares or some programs are available also. Okay, okay. Thank you very much. If you have any time, you can ask me any questions. Do you have any questions?